Okay, so we now come to the second talk, and our next speaker is Dillion Megida. In case you're not familiar, Dillion is a software engineer at ThisDot and a technical writer at many publications. He's passionate about learning, building, and simplifying topics around the web via articles and videos. And his talk title today is PropTypes versus TypeScript. So on that note, let's bring Dillion to the stage.
Hi,
Welcome,
everyone.
Dillion. You ready to share your screen?
Yes, I'm on it. Okay. Can you see my screen?
Yep, I'll share that right away. And we're live. We've got the 80s infinite loop hip.
Okay.
All right, the stage is yours, Dillion.
Okay. Hello, everyone. Good morning, good afternoon, good evening, wherever you are. So, my name is Dillion. I'm a software engineer at ThisDot, and I'm a technical writer at so many places. And in my talk today, I'll be talking about TypeScript versus prop types in respect to React applications. And this is what we'll be covering. So we'll be looking at props in React briefly, and then we look at prop types for props type checking, and then TypeScript for props type checking. We look at the similarities between prop types and TypeScript, and then the differences between prop types and TypeScript. And in this section 5, we'll also understand scenarios where you may want to use prop types over TypeScript, or where you may want to prefer TypeScript over prop types. And then lastly, we'll look at how to combine prop types and TypeScript in your application without repeating type declarations. So let's get started. Firstly, what is props in React? Props is a very familiar term in so many frameworks, Angular, Vue, React, and props are just like inputs, similar to attributes of HTML elements. They are inputs of a component that sometimes determines the returned React element. So as we can see in this small component here, this is a component, and then it has 4 inputs, which is 4 properties. And the first one is a BG color, the second one is an app name, the third one is items, and the last one is age. And these 4 properties are grouped into a property object. You can call it property, but usually it's called props. And that prop object is just like a regular JavaScript object. And just like JavaScript object, every property in an object can have different types of values. BG color here has a string, items here has an array, age here has a number. But then how do we ensure that the expected type for a prop is passed to that component, or a prop is indeed provided? Now, why is this relevant? Say, for example, in this component, you are doing a BG color dot to uppercase. If you pass in a number to this component and you try to call it to uppercase method on that number, that will break the application. So we have to ensure that when a component is expecting a string, it gets that string. And we do that by type checking props. And just like we see in this talk, you can type check with prop types and you can type check with TypeScript. So prop types for type checking. Prop types is a library. This is prop types right here. Prop types is a library used for declaring types for your props in React applications. And you can do that in various ways. You can declare array prop types. You can declare a Boolean type, a function type, a number type, a string type, a React element type, so many types as you may want. But then type checking when using prop types occurs during runtime. And by runtime here, I mean when the code is being executed, for example, in your browser environment. So if your code is not executed, you would not enjoy the benefits of type checking with prop types until your code is being executed either in development or in production. That's when your props will be type checked. And then just as we can see here, this is a simple way of declaring your prop types using the prop types library. So you have your function declaration here for your components. And then over here, you have this prop types object with different prop values and then the types. So over here, you have prop types.string, dot is required, this means the bg color prop should be required. So if you use this component without the bg color, you'd get a warning maybe in your console or in the terminal saying that there is a required prop of which you didn't provide. Then you have the app name, PropTypes.string, this is optional. You have the items, PropTypes.array is required, age, PropTypes.number, and so on and so forth. So if you had maybe an on-click property, you can also have it here and then use the PropTypes.func. Now let's say you're using this component and maybe you pass a number to the bg color instead of a string. In your terminal here, you get the warning, failed prop type, invalid prop bg color of type number supplied to component, expected string. So this is basically how you'd use prop types for type checking your React application. Now, there's something prop types, like I said earlier, prop types does its type checking during the execution of your code. And this is similar to what PropTypes does at the background. So you have this if statement here that does something like if type of bg color is not equal to a string, then print this warning to the console. So this is similar to what PropTypes does, and that's why your code has to be executed, because if your code is not executed, this if statement would never be executed. So now that's the basics of PropTypes. Let's look at TypeScript for type checking. Now, TypeScript is JavaScript, but with powers or superpowers. And TypeScript is used for static typing JavaScript applications. And static typing in this context here means that you are type checking even without the execution of code. Your code is not executed, you have static data in your code base, and then the TypeScript tools, the TypeScript plugins type checks your props just as it is like that, as a static application. So now props in React are just like regular JavaScript object, as we saw earlier. And since objects can be typed with TypeScript, then component props can also be typed. And this is a basic way of typing props in a React application. So this is the same component here. And then instead of using the prop types, we have this type alias up here, where we have the bg color to be a string. We have the app name to be a string, and then this question mark signifies that it's optional. Then we have these items to have an array of string values. So if for any reason you put a number value in the array, you would get a warning or an error. And then you have the age property, which is optional, and this should be a number. So say, for example, you are using the components and you pass a number instead of a string, you get this type warning in your ID saying type number is not assignable to type string. And also, if you run it in your browser, we could check that. If you run it in your browser, you also get the warning for your React application saying you passed a number whereas a string was expected. And let's wait for this to run. So this is the code base. I have the declaration over here, bg color, app name, items, and then the age. And then over here, I'm using the component, but I'm passing a number instead of a value. Okay, I would have to change that to TSX. And when the application is run, you can see type number is not assignable to type string. But then when you pass a string here, as long as the other types do not fail, everything works successfully. So that's it for TypeScript, and then we have seen prop types. Now let's look at the similarities between these tools. So the first obvious similarity is they are used for type checking. And when you type check with these tools, this helps you to ensure, or it gives a high guarantee that the correct value types are passed into props just as the component expects. So if you are trying to do a to uppercase on a string, there's a high guarantee that you are indeed going to get a string and not a number. And then the second similarity is these tools are used for development and not production. So for your TypeScript, because TypeScript gets converted to JavaScript, so your production code does not have any type checking for your props. And then for your prop types too, they only throw those warnings during development. In production, even if you are violating a type or you are not providing a prop, you would never get those errors in the console. So those are the two major similarities between these tools. And now let's look at the differences. And the differences here, this is the center of this talk. This is the major thing here in this talk, so I'd like us to pay attention. So although these tools are used for type checking, they work in different ways. And these different ways would give you this sense of preference as to why you may want to use TypeScript or why you may want to use PropTypes. And then some of the notable differences are the first one, runtime versus compile time. The second one is limitation of PropTypes for typing compared to TypeScript, e.g. conditional props. We'll look at that. We'll look at them in detail in the following slides. And then the last difference, which is a bit minor, is the IDE tools provided for TypeScript. Now let's look at the differences in detail. Firstly, runtime versus compile time. Like I've stated earlier, and like we have seen in the definition, prop type does its type checking during runtime. So without the execution of code, type errors cannot be caught. But then on the other hand, TypeScript does type checking during compile time. And compile time is where the code is converted from TypeScript to JavaScript. So during that conversion now, there is no execution. Even if you have a function call, the function would never be called. You are just trying to convert the TypeScript representation of that function to a JavaScript representation. None of the code is executed. And that is when TypeScript does its own type checking. So it uses your static value, it uses your hard-coded value, and then it converts everything to JavaScript. So during that conversion, if it notices a type violation, then it throws an error or a warning. Now, this is the major difference between these tools, and it greatly influences how these tools can be used. And we'll look at two use cases where one will be preferred over the other. And one of that use case is, for example, a data coming from an API. Sorry about that. So one of these use cases, for example, data coming from an API. So when you are type checking props using TypeScript, this can only be effective when the props value is hard coded. If the data is coming from an API, you would never be sure if that data is a number or a string. Even if you have claimed that this data is a number, if the data eventually becomes a string, you would never get a warning. But then unlike prop types, since prop types is just like your regular JavaScript and it is always executed, if you get a different type other than what is expected, you would get the error or the warning in your console. And let's quickly look at that here. So I have this basic example here, and that is in the API wrapper. So using the prop types, we are calling on, this is the app. I'm going to rename this to app.js since we're using basic prop types. So this app.js calls this API, this JSON placeholder API, and then it updates the state accordingly. And then it feeds that data into this API wrapper. And in this API wrapper here, we have used prop types to declare the types for our props. And we are receiving a to-do prop, which comes in form of this shape: completed, ID, title, user ID. And now I think I'll also print the data so you can see how the data looks like. And now if I restart this and run again, so if you're not familiar with the API, this is the JSON placeholder API. It's a free API that you can use for testing your tool. So this is what we expect. This is the value we expect in our React component. Now let's see how the component handles it. So we'll go here. Now, as we can see, invalid prop to do.user ID of type number supplied to API wrapper. That's because in the shape here, we specify that we want a string for the user ID. But then what comes from the API is a number, and then we get this warning. This is during runtime while the code is being executed. Now let's look at it using TypeScript. So I would rename this to TSX. I'll also rename this to TSX. The reason why I'm renaming this to TSX and renaming to JS is I have some TypeScript extensions that sometimes plays once it sees a TypeScript file, it may not interpret it like a JS file, so it begins to throw several warnings, which is uncalled for. So over here, I have specified that using TypeScript, I've specified that the use state should hold a state of the to-do interface or null. And this is the to-do interface here. It has a completed property, which is a Boolean, an ID property, which is a number, a title, and then a user ID. And then over here, I'll specify props this way. I'll remove this part here, and then I would attach this like this. This is just what we had with prop types, but now we're using TypeScript. And now let's see the error that follows when we run it again. So for our TypeScript here, user ID is a string, but the API returns a number. But just as we would observe, we won't get any warning or any error when we receive a string, because over here we have claimed that the user ID is a string. We are telling the API wrapper that the user ID is a string. Even though the user ID is coming from an API, we are assuring this component that the user ID is a string. But then when it becomes a number, we don't get a type number is not okay. I need to fix this part here. So I'll just clear off this part. Now we can see the application runs perfectly, no errors, no warnings. And that's because TypeScript only uses static data, hard-coded data during compile time. It doesn't execute any code. So if you tell it you're receiving a number, it assumes you're getting a number, even if that number or that data is coming from an API. And then that's one example. So in such cases here, if you would want to enjoy the benefits of type checking, you may want to prefer prop types to TypeScript in this case. Another scenario is, another scenario is, come on, what's happening? Okay, some reasons the slides, just give me a few minutes to fix that. Come on. Okay, don't know what's happening. Okay, I can no longer see my slides. Sorry. I'll share that again in a minute. Okay, for some reasons, my slides is not coming up. And I'm not sure why. Okay. Okay, sorry about that. So I'll just present it as it is. And I was here in the differences. So one of the difference here, one of the cases is data coming from an API. And then the second scenario is, say you are creating a shared library, a shared JavaScript library. Now, like I said before, your production code does not have TypeScript definition. So even if you're typing your React components with TypeScript, once they are pushed to NPM, the distributed version, they do not have TypeScript definitions. So the users of your library would not enjoy those type checking benefits. But when you're using PropTypes, since PropTypes is just like a regular JavaScript, regardless of whoever is using your shared library, they would always get that warning or that error when they violate a type error, when they violate a prop type. But then using TypeScript, you can also take the extra step of creating your declaration files and also publishing to NPM so that when your users install your React or your library, they can also install the type definitions and then they enjoy the type checking benefits. But then that's extra work because after creating your library, you have to go ahead to create your declaration files. So if you are creating a shared library like this, you may want to use prop types for your prop types. Now that is one difference. The second difference between prop types and TypeScript is that prop types is limited. Now TypeScript allows for many dynamics, many advanced things that you may want to do regarding types, and prop types is limited. For example, if you look at the prop types documentation here, this is all that there is for prop types. These are everything you can do with prop types. But then, like I said, props are just like JavaScript arguments. So that means you can do everything that TypeScript allows you to do with variables, with objects. One of which is you can create read-only props. And we can quickly check that here. So this place here, I can create a read-only prop called for the user.fullname. And if you go over here to try to reassign it, you get that error. With prop types, you cannot achieve something like this. And that's why prop types is limited. Another way that prop types is limited, another example I want to show us is conditional props. So conditional props is a case where you specify different structures of the properties object depending on another value. And this is how it works. So say we have this here. I think I'll just print all of that here so we can see it well. So let's say we have in this, I'll remove this part here. I'll remove this part here. So let's say we had authenticated, and authenticated is false. You can have another variation, authenticated true, and here you want full name to be a string. So this is called conditional props. And what this means is that when you specify an authenticated or false, you're not required to provide any other property. But when you specify an authenticated of true, then you are requested to provide a full name. And we can look at that being used here. So I'll just clean this off. I'll give this a string just as it wants. I'll give this a string just as the component wants, and then I'll give this an array of string, and then I'll give this a number. Okay, this is supposed to be the curly brace. Now for the user here, if I give it an authenticated, or false, oh, something is wrong here. Okay, yes. So if I give it an authenticated or false, you see that TypeScript no longer complains because it's not expecting any other property. But if I give it an authenticated of true, then it throws out a warning saying that I also have to specify the full name. Property full name is missing. So this is conditional props, and this is what I love so much. This is one thing I have done so much with TypeScript. But with prop types, you'd never be able to do something like this. So prop types is very limited compared to TypeScript. So if you are trying to do very complex things, then you may just have to sacrifice the runtime type checking and then just use TypeScript. And then the last difference, which is a bit minor, is that there are so many IDE plugins for TypeScript. Unlike prop types, because prop types has to be executed first, in TypeScript, TypeScript does static typing. So you can just create tools to analyze your source code the way it is and then run the type checking feature on it. So you have so many IDE plugins for TypeScript. And just as you can see here, I didn't even have to check my browser to see the type errors or the type warnings. Just right here, I can see it when I violate a type, or BG color was required, if you remember. And over here, I can see it's telling me BG color is missing. So there are so many IDE plugins for TypeScript. And if you want to enjoy the benefits of fixing errors while writing code, then you may want to choose TypeScript. Now we have seen the benefit, or now we have seen what PropTypes means. We have seen what TypeScript means. We have seen the basic ways of using them. But then how do you combine these tools? Because for someone like me, I love using TypeScript, but then I may also want to enjoy the runtime type checking benefit. And there are two ways to go about this. There are a few tools you can use. The first tool you can use is inferprops. And inferprops is a type, it's an exported type from the PropTypes library. I think we can look, it's an exported type from the PropTypes library. And over here in this Stack Overflow, which has a mini documentation of it, you can use inferprops from you have to install this because this contains the type definitions for the PropTypes package. So you can use the inferprops from this package, and then just the way you see it used here, you import inferprops, and then I think we can do that here. Do I remember doing it? Okay, I didn't do it for a reason, and I'll let you know in a second. So this is your types, this is your prop types here, and then you can do your type props equals to infer props, and then you are inferring the props from these types here. But the reason why I didn't do it before this presentation is the latest version of TypeScript does this automatically for you. So with the latest versions of TypeScript, even if I use a prop type here, I think I did that here. Okay, I didn't. So I'll just pick everything from here. It's from here. So the latest versions of TypeScript does this for you. So you no longer need to import infer props manually. So over here, I can just declare prop types, and I can pick all of these from here, put them here, and I can also, okay, now I just need to use prop types like this. And then that's it. So back here, when we go to the app.tx, I can remove these parts here. So now I do not provide, as you can see here, okay, I need to remove the props definition also. Let me comment this out. So here, I'm just using the prop types. I am not using the, okay, I didn't need to cut this part. I can just fix it here. I think TypeScript still does, yep. So I'm no longer using types here. I'm just using the regular prop types. But over here, you can see that property BG color is missing. And if you read between these, you'd see that a type called inferprops inner, which is also based on inferprops, was used to pick the prop types from here and then create a type definition for this component. But if you're not using the latest versions of TypeScript, you may have to go the extra step of doing this inferprops. I pick this and put it here, prop types, and then I'll have to do something like type props equals to infer props type of prop types, and then I attach it to this. If you're not using the latest versions of TypeScript, you may have to go the extra step of importing the infer props and then creating your type definitions like this. But like I said, the updated version does this for you. So with infer props, you no longer need to write, since you want to enjoy the benefits of both worlds, you no longer need to write your prop types and then write your type definitions. You can just write only your prop types and then TypeScript, and then the infer props handles the rest and makes it fit for TypeScript. But there's a limitation here, because there's a limitation here when you are trying to do some things that maybe TypeScript is not familiar with, maybe PropTypes.shape. It all depends on what the infer prop supports. So if the infer props only support string numbers, that's the highest that you can do. So that's it for infer props. And then the second tool is this Babel plugin called Babel plugin TypeScript to prop types. Okay, I almost call that prototype. So I have a little challenge here. When I tried using this tool before this presentation, I didn't get it to work. I think it has something to do with Create React app not allowing my Babel plugins to run as I expect, or allowing me to override my Babel plugins. But I'm still leaving this in this slide, still leaving this information in this slide. This is the link here. So you can go through it and maybe it would work for you, or maybe there's something I'm not doing right that you can do right. But then the purpose of the plugin is for generating prop types from TypeScript type definitions. So just like we saw with the infer props, we specified our prop types and then type definitions were created. With this plugin, you can have your type definitions created, and this will help you generate your prop types, maybe during compilation or during compilation, of course, maybe during your build or your develop. It will help you generate those prop types. So you no longer need to worry, you no longer need to write the definitions for both types. You just write it for only one, and then this tool fixes the other one for you. But then there are limitations here too, because TypeScript can be very complex, just like we saw with conditional props and then read-only. This plugin, I really don't know how advanced this plugin may be at the moment, but then this plugin may not be able to convert everything to prop types. But you are sure to have the basic type definitions converted to prop types as you would want. And then that brings us to the conclusion of this talk. So with all that you may have taken from my talk, this is one thing that I want to stick with you, is that TypeScript runs its prop type checking during compilation while the code is converted from TypeScript to JavaScript using Webpack, using Babel, whatever tool you may be using, Create React app, whatever framework. It does its type checking during compilation. And in contrast, PropTypes does its own type checking during runtime, during the execution of code. And this is what makes the tools different from each other, and this is what makes them unique in their own way. And that's it for TypeScript versus PropTypes. So if you have any questions, I would love to hear.
Dillion, thank you so much. That was quite a useful talk, especially for React devs working with TypeScript or coming into TypeScript. It can seem confusing, really making that distinction between runtime and compile time
Compile
checks. So
time.
thank you for that journey through that with all of the examples. Now, let's see if we have any questions. I don't see any questions coming in. And if none come in, then I'd use this moment to thank you once again, Dillion. Oh, okay, there we go. We have a question from David B. And that is, will Dino make the use of prop types obsolete while using natively TypeScript at runtime? Oh, that's an interesting question.
Yeah. Okay, so I'm not quite familiar with how Deno works, but as long as Deno can make TypeScript work at runtime, then I think you may not need a tool similar to PropTypes. Of course, PropTypes is for React, but let's say there is a runtime type checking tool for regular JavaScript. If there is native support for TypeScript at runtime, you may not need that tool. The main reason why you may want to use prop types is because TypeScript does its type checking at compile time and not at runtime. So if Deno supports that, then you may not need an extra tool.
Yeah, I believe we also had a talk about converting, actually taking types and generating runtime checks out of types. So doing it sort of the other way, instead of generating types from prop types, doing it the other way, taking the type and generating a validator object from that. So I can definitely drop the link to that. I think it was Emma Serino who gave that talk at one of the previous ones. Okay, great talk. Any recommendations how to convert, okay, JS components with prop types to TS props in bulk?
Okay, I do not have any recommendation for this. I want to believe that there may be tools online, maybe a plugin or maybe a website where you feed your code and then it brings the TS definitions, but I'm really not sure of any. My best solution for this is you would have to wait from prop types to TypeScript. Okay, my best definition for this is once you update to the latest TypeScript, I believe the latest TypeScript does this for you using the infab props that I mentioned earlier. So you just have to update the whole of the application to TypeScript using the latest TypeScript versions and integrate it with your React application. If you're not using Create React app, you may have to go the extra step of ensuring that they are coupled correctly together. And once you do that, I believe your TS definition should be intact. Yes.
All right. Dillion, thank you once again and hope to see you at a future meetup.
Yes.
All the
Thanks for
best.
having me. And I hope my session was helpful for React devs and TypeScript devs in general.